Hello students, from last class onwards we are discussing about gravitation. Okay, so in this class we'll discuss about free fall. Okay, so before I start this free fall, let me remind the things which are covered in the last class. Okay, so in this universe each and every body attract the other body, right? Yes or no? Okay, so if any body is earth, then that force is said to be gravitational force. Okay, so if I drop any object from a certain height, okay, then it moves downwards, right? It won't move upwards. Okay, it will it moves towards the earth or ground. Okay, why? Because earth is pulling the objects towards it. I already said a magnet example, right? When I have magnet, if I place a big magnet, if I drop two magnets, okay, so between these two small magnets also force of attraction is present, but these downwards magnet, okay, see, each and every object pulls the other object towards it. I said already. Okay, so if first let us consider this is a big magnet. Okay, big magnet, and these are two small magnets. These two attract each other, right? And again these big magnet also attract these two small magnets. Okay, so whether these two magnets will attract each other or they come and attract this big magnet, because they attracted towards this big magnet. Okay, this is a because magnetic field for these big magnet is more. The same thing happens here. Okay, if, see, earth acts as a big magnet, so it attracts each and every object towards its center. Okay, so this happened because of the gravitational force. The force of attraction is directly proportional to the product of masses. Okay, and it is inversely proportional to the square of the distance between them. Okay, so this is a universal law of gravity. We already discussed, right? Yes or no? Okay, so force is directly proportional to the masses, right? Okay, mass of the two object, and again force is inversely proportional to the square of the distance between them. So if I combine these two equations, what I will get, force is proportional to m1 m2 by d square. Okay, if I remove these proportionality, so I'll get a proportionality constant, that is g. Okay, g into m1 m2 by d square. Okay, so this is the force of attraction between any two objects. Okay, if any object is earth, okay, so if one object is earth, then F is equal to g into capital M, this is a mass of the earth, and small m, this is a mass of the object, and r square, this is a radius of the earth. Okay, so here what is a g? G is a universal gravitational constant. This capital G value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is a constant value wherever you can consider, on the earth and even on the moon, each and every planet. Okay, in universe this is a same value, that is constant, proportionality constant, 6.67 into 10 to the power of minus 11 Newton meter square per kg square. How we derived this unit? No need of remembering this unit, I already said in the previous class. If you are unable to view the class, just go to my YouTube channel and watch the previous video. Okay, next, so characteristics of gravitational force. Okay, let us discuss the characteristics of gravitational force. Okay, so in case of magnet, you can see the repulsion also, right? Yes or no? Characteristics of gravitation, gravitational force. Okay, so in case of In case of magnets, you can see attraction and repulsion. Like poles repel and unlike poles attract, right? But these gravitational forces are always attractive. Okay, so first characteristic is always attractive. Always attractive. Okay, always attractive, and it is a force at a distance, right? Yes or no? Okay, so even any object, if I drop from a certain height also, even though there is no direct contact between them, that is always attracted towards the center of the earth, right? Towards the earth, right? Yes or no? So force, it is a example for force at a distance. Okay, it is a force at a distance. Next, equal and opposite. Okay, so this is equal and opposite. Okay, so all the planets including earth revolves around the sun, right? Yes or no? Okay, so whatever the force applied by the sun, the same amount of force applies earth, even earth on the sun also. Okay, but why these earth is spinning over the sun? Because earth has a small mass, right, compared with the sun, so that's why earth is spinning over the sun. Okay, so but each and every planet apply equal and opposite forces on each other. That's why they are rotating or revolving around the sun in a equal distance. Okay, yes or no? Without moving or some if the attraction of sun is more than the earth, then what happens? This earth is pulled towards the sun, right? Yes or no? That's not happening, right? In case of any planet, that's it, not happening. So why that is not happening means those planets, each and every planet applies equal and opposite forces on each other. Okay, so even the moon and earth also applies equal and opposite forces. Okay, so these gravitational forces independent of intervening medium. Okay, so you can see on between the sun and moon, even vacuum is also present, right? Yes or no? So these gravitational force is independent of intervening medium. Okay, it will not depend on the medium whether the medium is present or not. Okay, so independent of independent of intervening medium. Okay, next, it is also independent of presence of other bodies. Okay, so even sometimes in between the sun and moon, earth also will come, right? Yes or no? You already learned in a light lesson the eclipses, right? Solar and lunar eclipses. Okay, so in between earth and sun, even sometimes moon also will come. So but these gravitational forces decreasing at the time, no. Okay, so it is independent of the presence of other body. Okay, in between these two bodies, even if the other body also coming, it's not cares about that. Okay, so the force is always constant and equal and opposite. Okay, next, force acts along the line joining of the two centers. Okay, always these force of gravity acts along the line joining the two centers. Okay, so suppose these are the two bodies, these force acts along these centers. Okay, line joining the two centers. Okay, it's a long range force. Okay, you can see between the earth and sun, so many light years distance is there. Okay, so even though they are attracting each other, though they are applying force on each other. Okay, it's a long range force. Okay, so it's a long range force. Okay, if we increase the distance between two bodies, force decreases but it never becomes a zero according to inverse square law. Okay, so you know force is inversely proportional to distance between them, right? If the distance is increases, the force becomes or decreases. Okay, inversely proportional, right? But it never becomes a zero, so it's a long range force. Okay, and it is weakest force in the nature. Okay, it is weakest force in nature compared to the other forces like electrostatic force, magnetic force, and nuclear force, or stronger than these for gravitational force. Okay, it is a weakest force in the nature, and everything is pulling everything in this universe, right? Yes or no? So these are the characteristics of gravitational force. Okay, these are also very important. So when the gravitational force applies, and what about the nature of this force, everything is here. Okay, so these are the characteristics of gravitational force. Okay, so let us discuss now about the free fall. Okay, so um, we already discussed about the forces acting on a freely falling body in the previous lesson, that is in motion, right? Yes or no? Okay, so what happens, free fall is a motion of the object, right? Yes or no? Okay, so on the freely falling body, only gravitational force acts. Okay, so gravitational force is equal to 9.8 approximately, will take a 10 meter per second. Okay, even for second square, for each and every second square, it will, the acceleration is 10, right? 10 meters. So only the gravitational force acts on the freely falling body. So that freely falling body also said to be accelerating body. These things we already discussed in the motion lesson. Okay, so free fall is a motion of an object. Let the body be free under the influence of gravitational force due to the earth alone. Okay, so here resistance is neglected. Okay, here resistance is neglected. Whenever an object is falls freely towards the earth and acceleration is involved, this already discussed in the previous lesson, the acceleration of the freely falling object is called acceleration due to gravity. Yes or no? Okay, so that is G, we already learned. Okay, so free fall is the motion of the object. Okay, so free fall is the motion of the object. Okay, so let the body be free under the influence of gravitational force to the earth alone. Whenever the object falls freely towards the earth, the acceleration is involved, right? So the acceleration, so the acceleration of a freely falling object is called acceleration due to gravity, that is small g. Okay, so let us drop a paper and a ball from a certain height. Okay, so certain height on the earth, those two objects are pulled by the earth, right? Yes or no? So which object will reach the ground first and which object reach later? So both the object, irrespective of their masses, they reach the earth surface at the same time. Okay, so if the slow motion recording option is there in your phone, try to observe these motions. Okay, if you drop a heavy ball and also lightweight ball, okay, it's a difference, okay, you can notice the difference. But if you drop a paper and ball, the ball reaches the ground early, okay, because its mass is more, right, and paper mass is very negligible, so that's why this air resistance influence its motion, okay. So that's why if you want to do this by recording the slow motion in your mobile, try to drop a lightweight object and a heavy object like a stone and a plastic ball, okay. You can see by recording in a slow motion, those reach the ground at the same time, okay. So whenever the object mass heavy or light, both takes the same time to hit the ground. But in case of paper and a ball reaches early because paper is lightweight, so air resistance resist the motion. But if we create a vacuum in a box, okay, so paper, it will influenced by this air resistance, right. So the ball mass is more, so that's why the air resistance is may not influence this ball, okay. So that's why it reach early to the ground. It's here air resistance is present. Air resistance restrict the motion. Here air resistance will not restrict because mass is more. So if you able to create a vacuum, okay, and try to observe this paper, and I'm using a pump and I'm evacuating this box, and I'm dropping a paper and ball again. Those reach, these two reach uh, in a same time, because here no hair, right. So no hair means air resistance is not present, so that hair resistance will not stop the motion of this paper, okay. So irrespective of the mass, okay, whether the heavy mass body or a lightweight mass body, both reach the earth at the same time, because the acceleration due to gravity is 10 meter per second square, okay. In a lightweight body or heavyweight body, in both the cases, the acceleration due to gravity is 10 meter per second square. That's why they reach the in the same time, okay. So let us find the acceleration due to gravity, okay. Acceleration due to gravity. See, we already discussed if the two bodies, any two bodies attract each other, right, okay. In those two bodies, if one is earth, so that is it's coming to case that gravitational force acts on that, okay. So if any object is earth, then force formula, okay, F is equal to capital G small m and capital M by r square. Just now I said, right, yes or no, this is the mass of the earth, radius of the earth, and G is gravitational constant, you already know. The this M is object mass, okay. So here distance is always will take a radius of the earth, okay. So let us consider this is a equation 1, okay. So from Newton's first second law, you know already, F is equal to ma, right. This is Newton's second law. From Newton's second law, F is equal to ma, we already know, okay. So here m is acceleration. In this case, we'll take a a is equal to, see a here acceleration, right. In this case, we'll take this acceleration as acceleration due to gravity. So F is equal to m capital G, okay. So this is the equation 2, okay. So here observe LHS and RHS, LHS and RHS. Here LHS in the both the cases force, right. So I'm equating these to RHS side. LHS is equal, then we have to equalize RHS side, okay. So what happens here? Equate RHS sides of equation 1 and 2. Okay. So then what happens? Mg is equal to capital G into small m capital M by R square. Here the same small m, these are mass of the object. I am cancelling these two. So now what is left here? G is equal to capital G m capital M by R square. Okay, so this is the acceleration due to gravity formula. Okay, so what is this? This is acceleration due to gravity. Okay, this is acceleration due to gravity. So let us find the acceleration due to gravity value. Okay, because here see, observe this G, universal gravitational constant, we already know, and mass of the earth is also a constant value, and radius of earth is also a constant value. From these three constants values, can we find these value of the G? Yes or no? Okay, let us find the value of acceleration due to gravity. So let us find the value of acceleration due to gravity. Value of acceleration due to gravity. We already derived the formula, right? Yes or no? Okay. So G is equal to capital G capital M by R square. This is a formula. Okay. So what is the G value here? 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Okay, this is a value. Next, what about the mass of the earth? Mass of the earth is 6 into 10 to the power of 24 kg. Okay, divided by, here kg cancel, one more kg left here, divided by radius of the earth, that is 6.4 into 10 to the power of 6 meter square, because r square at square here. Okay, so I'm separating values and 10 powers. Okay, 6.67 into 6 divided by 6.4 into 6.4. Okay, so this I'm writing the 10 powers in a graph, I mean bracket. 10 power 11 into minus 11 into 10 to the power of 24 by 10 to the power of 12 here. Okay, and here meter square, right? Newton meter square by kg meter square. Kg, I mean these two cancel. Next here this 10 power 12 plus 12. If I bring these two numerator, then it will become minus 24 minus 12. It becomes a 12 in the upside. Okay, so 6.67 into 6 by 6.4 into 6.4. Here 10 power minus 11 plus 24 minus 12. Okay, and see here you will get these minus 23 plus 24, 24 minus 23, 1, 10 power 1 means 10. Okay, so if I multiply here, what happens? 9.81 meter per second square you will get to, that is approximately is equal to 9.8 meter per second square. Okay, so this is the acceleration due to gravity value. Okay, so like this we will find the acceleration due to gravity value. So if the object is heavy or light, that 9.8 meter per second square acceleration acts on them, so they reach in the same time. Okay, so acceleration due to gravity does not depends on the mass of the object. Observe the equation here. G, universal gravitational constant, m is the mass of the earth, and r square, that is the distance. Okay, but is there any small m value here? No, so there is no small m value, is nothing but this acceleration due to gravity does not depends on the mass of the object. Okay, so here in this formula G is equal to, I mean small g is equal to capital G by small capital M by r square, right? This is the mass of the earth, right? Yes or no? So you will get a for 1 mark. Write the formula for acceleration due to gravity, and these terms also we have to mention. This is a radius of earth, mass of earth, and this is universal gravitational constant. Okay, so no small m term here means the universal gravitation, I mean acceleration due to gravity, does not depends on the mass of the object. Okay, so next, gravitation on the this g value on the moon. Okay, so gravitation on moon. Okay, so what is the um, acceleration due to gravity, right? Okay, so this acceleration due to gravity value on the moon. Okay, so we can find for moon also, right? Even for any planet we can find, because here in place of mass of the earth you have to place the mass of the moon or mass of the any other planet, and the radius of the moon or radius of the that planet. You can place these two values of the particular planet, and g value is constant each and everywhere in the universe. So from this formula you can find the acceleration due to gravity um, on the earth or on the moon or any planet you can find. Okay, some finding on the moon, mass of the moon by radius of the moon. Okay, so that, so mass of the g value 6.67 into 10 to the power of minus 11 into 7.36 into 10 to the power of 22 kg. Okay, and by 1.74 into 10 to the power of 6 whole square. Okay, so try to simplify these. Okay, 6.67 into 7.36 by 1.74 into 1.74. Okay, into 10 to the power of minus 11 plus 22 minus 12. Okay, so here you will get a minus 23 plus 22, so minus 10 you will get 10 power minus 1 you will get. So g of moon is equal to 1.62 meter per second square you will get. Okay, so gravitation acceleration due to gravity of earth is equal to how much? 9.8 meter per second square. Observe the values here. Find the ratio of moon to the g of earth, small g of earth. How much you will get? 1.62 by 9.8, that is equal to 1 by 6. Here g earth is greater than the gravitation on the moon, right? Yes or no? This is 1 by 6 times, 6 times more than gravity on the moon. Gravity on the earth is equal to gravity on earth is 6 times more than gravity of on moon. Okay, understood the free fall and acceleration due to gravity formula, and how to find the acceleration due to gravity value, and even gravity on the moon also will found. Okay, so this is the end of this concept. Okay, so in next class we'll discuss problems and everything. So we already completed motion and matter around us, right? Yes or no? So motion, there are lot of formulas you have to practice. Okay, so one more video after completion of this lesson gravity, we'll make 2 more videos on the motion problem parts. Okay, so if you miss any video of your lessons, okay, try to go to my YouTube channel, that is Okay, you already know. So this, try to go and watch the missed videos. Okay, thank you.